Hey folks, welcome back for another episode of Code Club. If you are just joining for the first time, my name is Pat Schloss, and I love going through the scientific literature, finding data visualizations, such as this one here on, I guess as you're looking at on the left, I think. And so this is a figure that was published in Nature Microbiology, a couple of weeks ago. And if you missed it, a couple days ago, I posted a video where I did a constructive critique. And so my goal for today isn't to rehash that critique, but what I would like to do is to recreate this figure as the authors presented it originally, warts and all. And then what I'd like to do is make a couple subtle changes to I think, enhance the interpretability of it, and then to go back to what I think it should be, and that this is really what's called a volcano plot, but instead of drawing it in Cartesian coordinates, so basically a volcano plot on the x-axis would have the log fold change in base 2, and the y-axis would be the p-value in log 10. They put it into radial coordinates, making them circles like this, right? And so let me kind of share some links with you. And so this is the article that the figure came from. This is figure 1. And again, if we go to the figures and then figure 1 here, we'll see those radial volcano plots. And so this figure, to give you a little bit of background, is part of a screen that they did on Trypanosoma brucei, where they're looking for different proteins that interacted with this VEX1 or VEX2. Okay, so that's the extent of my understanding of the biology, and I think that's really all we need to know. And so again, they made these kind of 3 different screens with using VEX2 as a bait at different sides of this turbo protein, and they also used VEX1. And then they got the positive hits, and then they kind of fed them into these Venn diagrams. And so one of the things that I'm going to come back to is the function of these figures, so panels E, F, and G. And in my mind, the function of the panels is to help us to understand the values that are going into these Venn diagrams here in panel H especially, right? And so like this VEX1 circle corresponds to panel G. I'm pretty sure the VEX2N is E and F is this purple, right? And so I think they kind of lose sight of that. As we've talked about, like they kind of use different definitions. So here, the purple are enriched in the biotin samples. That's the samples with the bait. And so they have like this p-value, but they don't say anything about the log fold change. Whereas down here, they have log fold change base 2 greater than 1.5, p less than 0.05. But again, if this spoke on the circle is 1, then 1.5 is here, and yet they have purple points that are less than 1.5, right? So those are kind of something that's going to be sitting in the back of my head as I think about recreating this. So as you are joining in, I've seen some people doing this already. Please feel free to say hi, tell us where you're joining from. The other thing that I will share with you all, if you're not on my newsletter, once a week I send out a newsletter by email, and I talk about different data visualizations. Usually it's the data visualization that I'm going to be talking about, say, today. And so here you go. Here is the radial volcano plots. As I point out in this newsletter, one of the things I struggle with, and I think maybe you all get the sense of that, is that I'm making visuals oftentimes that I don't think are good, right? And I mean, I think everything has room for improvement, but I'm making visuals like this week's that I don't think are particularly effective. And so what I talk about in this article, in this newsletter, is like, why? Why do I recreate this figure? And what do we have to learn from it? Because I think it is valuable to recreate something, even if you don't like it, so that you can then know what you want to change, right? You can learn something about the data. And then I think like the third really important thing is so that you can learn your tool better, right? So, this figure does something that I think is kind of cool that I'm curious how to do in R, which is namely this legend on the bottom has 3 plotting symbols for one label. How do I do that in R? Okay, so we saw something like that last week, again in another plot that I didn't really like, where they had a legend where they made section headings like this, right? And so you'd have to go back and look at the live stream to do that. And actually, I've been thinking about making a video to show how to do both of these things with legends in a standalone shorter video, because it's basically the same method. So if that's something that interests you, let me know in the comments or here in the chat. That would be awesome. And then if you missed the critique video, let me go ahead and paste that here. I kind of caught my mouth in a weird position there in the screen grab, but there you go. Okay, so let's see who's been joining in. Looks like we've got some new people. So we've got Hassan from West Virginia, Code with Biologist. Not sure where you're from, but welcome. I think you're new. Mike from the UK, John from Barrington, Lori from Toronto, welcome. We have Edie, I believe, from Portugal. Sorry for the mispronunciation. James, also from Toronto. Fabian from Germany. And yeah, so welcome. And as we go along, if you've got questions or comments or thoughts, feel free to share them. I am slightly concerned that I have bitten off more than I can chew in doing this data visualization. And so I've been doing a little bit of background work to get going on it. And so one of the things that I've already done, because it was kind of hard for me to kind of figure out on my own, frankly, was what are the genes that are purple in the plot. And so I have the validated gene names. These are the ones that are purple in these plots. And then these 5 gene names are the CAF genes, the VEX1 and VEX2, which again are these teal, maroon, and goldish color, okay? Eddie, okay, thank you. And we've also got Joje from Sweden, and John saying yes for a separate video. Okay, well, I'll just have to work that into my schedule. All right. So, as always, I try to pick figures, or I do pick figures from papers that are open access and that preferably have source data available. And so, again, if you'll know there's source data available, if you go in Nature at least to the bottom of the caption, there'll be a link to source data. And then that brings me to this link that if I click on it, I download the Excel file. So I'm going to go ahead and copy that link address. And let's go in here, and I'm going to do download.file. And we need to give it the URL, which is that behemoth. And then I will call this figure1.xlsx. And so that will save it to my local directory. And there we go. And so for some reason, I named this directory radialvolcano.r, which is not what it should be, but whatever. That's on me. So again, we've got that file downloaded. And let's go ahead, and before I do anything else, because I'll forget, I'm going to go ahead and load all of this into R. And so we've got all those variables stored now. And yeah, let me open up figure 1 XLSX so we can get a sense of what it looks like before we get going too far here. And let me zoom in. So we've got E, F, and G. Actually, when I first saw this plot, I wanted to do it. I saw it, I was like, oh, I got to do that. Please tell me you made the data available. And sure enough, they did. As I was logging in, I was kind of finding the page, I was like, please, 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 please. And sure enough, here it is. So anyway, here we see we have the gene ID, the log fold change. They also provide like the average expression level, the t-value, the p-value, the adjusted p-value, and then B, which I think is the concentration for the biotin, I want to say. Really, all we care about is gene ID, log fold change, p-value, and then adjusted p-val, okay? And then we've got that for E, F, and G. So one of the things that I don't think I commented on in the original video was that these 3 panels are not aligned with each other. I don't know if you can see it super well, but like panel F is like a millimeter lower than panels E and G, which again tells me that they took these 3 plots, or all the plots that are in this figure, and pulled them together in Illustrator, tried to line them up, and then made the thing, right? So what I would like to do is, I could use patchwork, but what I think I'll do instead would be to use a facet. So I'm going to read the 3 sheets in together and then make a faceted plot. Okay, so that's going to be my strategy in this video. And yeah, so that's 1E, 1F, 1G. So what I can do is read Excel, and we'll do figure 1.xlsx sheet equals 1E. And I'm feeling like I'm already having a brain fart. Let's try this. Read Excel underscore. I put a dot. Okay. There we go. So that reads that in, right? And so again, we've got those same columns that we had in the workbook. And I could do this 3 times for 1F, 1G, right? And it reads in the same way. But I want this to be read in, these 3 sheets to be read into a single tibble. And so to do that, I can do bind rows. And we'll basically have these 3 sheets that we're going to read in and bind together. And I'm going to read these in as like a named vector, right? So I'll do like E equals this, F equals this, and G equals that. And so what that does is that I can now see that I've got 6,000 rows, right? Whereas before I had about 2,000 rows per panel. But I don't know what panel these came from. So to get that, I can come in here and do .id equals panel. And so now I get a column that's panel, right? And so now I have one monster data frame that has all of the data for the 3 panels. And to clean this up a little bit, I'm going to go ahead and do a select on panel. I'm going to do gene underscore ID equals gene ID, and then we'll do log FC, and then we'll do p dot. I'm going to do p value equals p dot value, and then adj dot p value equals adj dot p dot val, because that's just going to get too confusing to have those different names. All right, so I'm already screwing up. Doesn't have p dot value. What was it? Oh, see, I already did it, right? So that's a capital V, and then this is also a capital V. Anyway, there we go. So now we've got our columns narrowed down, and we're off to the races, all right? Cool. So we've got our data read in, and let's go ahead and make like a traditional volcano plot, okay? So we'll do ggplot AES. Again, on the x-axis, we are going to put the log FC. On the y-axis, they have, well, I'm not sure if they plotted the p-value or the adjusted p-value. So let's do p-value, and then we'll adjust to adjusted p-value if needed. And that should be good for now. And then we'll do geom point, and then I'm going to do facet wrap, and we'll tilde on the panel, and we'll do nrow equals 1, okay? And yeah, so, and then I've also got a save statement down here that should get me what I want. There. All right, so let me shrink this down a little bit. And I prefer to make things in the dimensions of the original plot, so that it's kind of easier to see what's going on. And so, all right, so right off the bat, there's a few things I see here, that we've got the log fold change on the x-axis, but I have the p-value rather than the log p-value. So let's go ahead and do that. So we'll do log 10 on p-value. And we've got that, but on a traditional volcano plot, it's negative log 10, right? And so there we go. We now have the log fold change on the x-axis, and on the y-axis, we have the negative log 10 of the p-value. So one thing that I commented on in the critique video is that they're saying that they did negative log 10 of p here, but they've got negative values on the radius axis, on the y-axis, which is impossible for a p-value, right? Because if you had, if you have log 10 of 0.5, that's going to be negative, right? And so you couldn't do like negative log 10 of 0.5 and get a negative value, right? Like it just doesn't work. And if we did it on 1, which would be like the largest possible p-value, that's going to be 0. And if I did like 1e to the minus 10, again, that's going to be 10. So I think they would have really been helped if they had plotted the negative log 10. But I think it's really just the log 10 is what they plotted. So for now, I'm going to go ahead and remove that negative, which again flips it. And so now you can see that we have the values going from 0 at the top to negative 12 on the bottom. The other thing that I commented on, and again, this is, I think, why it's valuable to recreate other people's plots, even if you don't like them, is that they have negative log fold changes. And I think for their screen, it doesn't make sense to show the negative log fold change, but they also didn't say that, right? They didn't point out that they were only looking at the positive log fold changes. So something that we should go ahead and do is to go ahead and do a filter on log fold change to be greater than, and I'll say greater than equal to 0, because why not? And again, if I were rewriting the caption, I would say we're only looking at the positive log fold change values. And so there we go. We have the positive log fold change values here. Great to have you, Saeed, from Somalia. And yeah, all right. So again, this is like the flip of a traditional volcano plot, and we'll come back to that. But what I want to do again is to make these radial volcano plots. So to do that, it's going to be, so James said that confused me for about an hour when I was trying to recreate the figures. Yeah. Is to add chord radial, right? So what we already have is chord Cartesian, so traditional XY axes, but with chord radial, we'll be able to hopefully get it to look like the panels on the bottom. And there we go. We now have the makings, I would say, of these plots that we see down below, right? So again, we have the log fold change around the outside, and then the radius is the log 10 of the p-value. And cool. So a couple things to get going here is that we've got, they've got the expansion added. And so the expansion is, if you're familiar with like a bar plot in R with ggplot2, that's what adds kind of padding below 0, which drives some people nuts. But in this case, it adds padding around the perimeter, but it also adds padding inside here, right? So like this sector here, which is, I think between 7 and 0, has nothing in it, but that's the expansion. So let's come in here and we can do expand equals false. And so now we can see, oh, let's see. I think this is 0, 2, 4, 6. Or no, this is 0. This is 0. I don't know. I'm kind of confusing myself already. Or maybe the 0 is right here. Yeah, so I think the 0 is right there. We're just not seeing it. So let's go ahead and I'm going to do scale. So again, I have to think between x and y and radius and theta. So scale x continuous is going to be the theta, right? And we can do limits 0 to 7. And so that gets us 0 at the top, and then 7 is also at the top. But you can see that there's a line here for the 7, right? So maybe what we could do would be like 7.1. And so now we've got that line, and maybe it should be like 7.2, right? So basically we're throwing this wedge in here. And that might be a little bit too big, whatever. I'll do 1.5 or 0.15 and I'll stop futzing with it. So there's our radial volcano plot. And so hopefully you can already see the makings of what they did, right? And that like this yellow point here for the CAF1B corresponds to this here, right? And then this is also CF1B, so is that, right? So we can kind of see these points as we go through. All right. So let's see what to do next. I'm going to go ahead and get rid of the axis titles, because ultimately I think this negative log P10 or log P10 could be part of the title of the facet. And then this down here in the lower right corner is serving the same function as this. So just to kind of get us more room, I'm going to come in and do labs, x equals null, y equals null. And so then that, again, blows that out. I've already done some work with scale x continuous, so let's do scale y continuous. And we'll do limits equals c. And so that goes from -12 at the center here, right? And so this, again, was something that threw me off, was that there's 0 here at like 12 o'clock on a clock face. But that's for the theta. That's not for the radius. This right here, where my cursor is actually the 0 on the radius. And so I think it actually goes out to maybe 0.8 or 1. So let's maybe do 0.8. Add that in. And so, yeah, so again, -12. And then it's going every 2, right? And so then in here, we could do like breaks equals, and we'll do seek -12 to 1 by 2, right? Yes, by 2. And so we have in here like the minor grid lines as well, which, yeah, I don't want to worry too much about that, but let's go ahead and get rid of those. Just so I'm not like getting dizzy looking at all those grid lines. So we'll do panel.grid.minor.y. So that's the radius. I'll do element blank. There we go. And so that's more like it. And yeah, okay. So we'll pause there and let's see. Let's now bring in the coloring, okay? And maybe we could let's go ahead and make our points smaller, because again, like these points over here, the gray points in the bottom are quite small. And I think ultimately we're going to have several different sizes. So we're gonna have different colors and different sizes depending on what the protein is. Yeah. So let's go ahead and do size first. But to do size, I have to make a column that is going to get mapped the size, right? And so we'll come back up here and we'll do a mutate. And what should we call this column that we're going to map the size to? Let's do size equals, and I'll do group. Let's do protein group, okay? And so we now need to make the protein group, okay? And so I'm gonna do this with a case when. So case when gene ID, and let's see. Oh, actually, it should be gene underscore ID, and I should probably put this after the select. All right, because I don't have gene underscore ID before that select, right? And maybe just for organization, I'm gonna move that filter log full change down below. And I should also go ahead and point out here that you can get all of the code that I'm generating here. If you go down below in the description, after the live stream is over, you'll find a blog post where you'll get all of the code that I'm generating today, okay? So we're gonna do case when gene ID. So we need to think about like the order that we want to do these things in. And so I think what we want to do is if, well, there's the validated and then there's these like known targets, right? So let's go ahead and do gene ID %in % validated. And then I'm going to say validated. Okay. And then gene ID %in %. And then I'm going to do C, and here we'll do CAF1A, CAF1B, CF1C. So if it's one of these three, I'm going to call that then CAF. And again, what I'm thinking about here is that I want to, I'm going to change the color for these different groups and also the sizes for these different groups. And then, and the way case when works is that it's going to go line by line. So if this is true, then it kicks out to the next function, right? But if this is false, then it's going to go to this line and it's going to keep going. So like the final thing that I might want to think about is if the p value is less than 0.05, then I'm going to say significant. And I don't know if it's p-value or adj.p-value. I think it should be adj.p-value, but I have suspicions, so we'll hang out there for now. And then finally, for the true, so that's basically anything that doesn't fit into these three categories, right? So like these three categories fit into, let's see, do they? Oh, I forgot the vexes, right? So we also want like the vex, well, I'll say gene ID equals vex1, and then here I'll say vex1, and then here we'll do vex2. Okay. And now, so again, this line, the validated, is going to be this pinkish reddish circle. These three lines correspond to the vex known interactors, right? And then this is going to correspond to the purple dots, right? And so then this true is going to be for the gray dots. That's going to be everything else. And so I'll say non-significant, right? And maybe because everything is black, or let's go ahead and make this color for now, and then we'll come back and do size later. So again, what I've done is I've made a column called protein group, and we're going to change the size of the points and the color of the points by whether a protein is in that protein group, okay? And it's upset with me, probably because I forgot a comma or something somewhere. Oh, yep, I put the parentheses over there when it should be here. Okay, no errors, good, good, good. And so now what we see is that we've got our different colors, right? And so like this red is for the calf. And so like we can see probably most easily over here in G, the three red points for the calf. And then I'm missing vex1 and vex2. And oh, I think that was because I put it as a string, right? When this is a variable. So if gene ID is vex1, then it's going to be assigned to group 1, right? Because I made vex2 a gene name. Okay, so now when we try that, now what we get is the vex1 is a blue, which I can see here on F, which corresponds to here, down here, and then vex1 over here is over here, right? And then vex2 I think is kind of like, well, it's there, right? So we can kind of see where the points are. Cool, huh? All right. So because I'm worried about, well, let's go ahead then and add in the size. And so we could also do size equals protein group. And so it's saying using size for a discrete variable is not advised. We'll deal with that in a bit. but we can see that we've got 6 different sizes, right? So that's not what we want either. So cool. We're making the plot, right? Hey, Max from Uppsala, welcome. Great to have you. So let's go ahead and let's customize the colors, or let's do the sizes first, perhaps, right? So to do that, I'm going to come back up where I have my other scales. I'll do scale, size, manual, and I will go ahead and do name equals null, and then I'll do breaks equals, and then we've got these 6 categories, right? And so let me get some room so I can see everything. So we'll do validated, calf, vex1, vex2, significant, and then non-significant. Okay, so those are, well, let's do values, right? So do values equals those, and that way we can then use like the named vector. So the non-significant are the smallest. Let's try 0.5 for now. And then like these vex known interactors and the validated ones are all the same size. Let's make that 3. So I'll do equals 3. Again, these are the sizes, and we'll probably have to do some tweaking along the way to make sure we've got the right sizes. And then this vex2 is also 3. And then the purple is the significant ones. So those are smaller than the non-significant, but larger than the non-significant, but smaller than the other ones. And so maybe I'll make that 1. Okay. And let's add that in. And so now we can see that we've got those points. And we're kind of like, let me get the color right, and then we can perhaps hide the legend for now. And then we'll kind of let the panels expand and blossom so we can get a better sense of how our sizes are looking. So let's go ahead and turn to the color now. And so for the color, we'll do a very similar type of thing, where I will do, and you know what? I'm thinking about this, and one of the things that I commented on in the critique video is that for some of these, like in the original, it's a bit hard to see kind of the boundaries on some of these points, right? Like this over here, it's 2 purple dots kind of close to each other. And so we want to get rid of that. The other thing I'll point out is that in the critique video, I also commented on how they had like an alpha for the purple and the pink and the gray. I don't want to do that just because I don't think it is attractive. And I don't know if you can see it with the resolution of the PNG here, that they appeared to plot multiple layers of the same data over and over. So like this purple dot has one of those gray dots behind it, right? And then like this red dot has a purple dot and a gray dot. You can see that much better in like the PDF version. And so what I'm showing in mine then, if I kind of go to the same area, I guess these are opaque, but like if I were to make mine, if I were to do like alpha equals 0.2 and zoom in, there's no point behind that, right? Something you do see is like this kind of radius around it, and that's an artifact of the alpha, which I don't know why it does that. It's kind of odd, but so I'm going to go ahead and turn off that alpha. And I'm going to do shape equals 21. And so then we'll do scale fill manual. And then for my color here, I'll do black. And this reminds me that back up here, I did color. So let's make this fill. Okay. And then, well, for now, let's turn this off and see what it looks like. Right, so that's kind of the look. That stroke is probably too thick, but again, we'll come back to that. Things are kind of compressed right now, but like I said, we'll come back to that. So let's get the color right. And so I have my handy dandy color monitor. And one thing that I've noticed, if I zoom in on these, is that the colors that are in the legend are not the same as the colors in the plot. So this is like 02, 92, 93. Well, that's right. Let's see, this burgundy, 94, 16, 50, 95, 17, 52, right? And then like this gold, FEC102, FF or FED600, right? So like these are different colors, slightly different colors, which again, I think points to that they probably used Illustrator to compose these three panels together and make their own legend. But I'm going to do it all in R. So anyway, I will go ahead and use these colors. And so that is for the Vex 1. So let's uncomment this and get that. And then Vex 2 is this maroonish color. And get that. And then the calf. I didn't really like the CAF either because in some of these, like over here in panel F, the text just gets really washed out, right? So we'll get that. And then we need the validated, which is the this reddish, right? And throw that in. And then the significant are the purples. And again, those have like an alpha, but I'm just going to grab this bubble here from the legend. And again, those are the significants. And then the non-significant is the gray. And if I come over here, I'll get like the full alpha. It's 86, 86, 86. All right, so let's just clean this up real quick. Right. And so there we go. We have our colors and our sizes varying. Cool. So I'm going to go ahead for now and turn off the legend. And so I'll come back up to geoPoint. I'll do show.legend equals false. Right. And so let's zoom this out. Okay. So I think what I'll do is I'll go ahead and shrink the stroke. So the border of those plotting symbols like 21 through 25 is the thickness of that is set by a parameter or a static really called stroke. And so I'm going to do 0.1 to keep it really thin. And so you can see now that that made that pretty thin. I think my points are too small. So my circles, my individual circles here are about the same size. I think like the bigger circles, like the known interactors and the ones that were validated in the study are the right size. But I think the purple and the gray are too small. I think the purple is probably the size that the gray should be. So let's make this 1, and then let's make this 2. There we go. And so, yeah, I think that's pretty close to the right size. And looks good. One thing that I commented on in the critique also was the layering of the points. And so you can see that mine already are in a different layering than theirs, right? Like this red point is buried underneath all the gray points. And I think what I'd like to do is to put the known interactors, well, I'd like to put the gray ones on the bottom. And I want on top of that, maybe the known interactors. And then on top of that, the ones that were enriched. And then the ones that are validated on top of that, okay? So whenever you're thinking of like ordering of things, we can do that with a factor. So we'll come back up and add to this mutate, and we'll make protein group actually the factor. So we'll do protein group equals factor on protein group. Okay, and then we'll do levels, And let's bring that over so I have some more room. And so on the bottom, I want to put non-significant. And then above that, let's do vex1, vex2, and the calf. And then let's do validated, or significant and then validated. We can always change it. And bring that over. And so that didn't change anything. And I think that's because I need to sort the data by the protein group. So I can sort it by doing arrange on protein group. And so now we can see the order change, right? That now we can see these red points are on top of the gray points. And we can see the validated points on top of the significant points. And so, whereas like the known interactors are in the background. So I think we could maybe disagree on what order to put things, but I think the value in, like my logic here is that I don't really care about the non-significant ones. They're in the background, right? And so let's put them at the very bottom, right? So then the known interactors are known. And so as long as I can just see a sliver of them, kind of like this yellow point here or that yellow point there, then those can also be in the background. And what I want to see is like new stuff, right? Like I want these panels to show me what's new. What am I learning from this screen? And so those purple points are on top then. And then on top of that, we have these red points. And so again, those red points are the points, or the proteins that they validated further, right? So again, that's just kind of my thinking a little bit. I see this comment from Miguel that I think this might be too busy. Yes, yes, it is busy. And so there is a bit of my thinking. And I think already you can see the points a bit more clearly than what you could in the original. Like I said, we might quibble over the ordering of like these different protein groups, but I think this will work. So let's leave that now. And let me think about what we should do next. Let's go ahead and let's see. Let's go ahead and I'd like to work on this arrow briefly, okay? And so I think they kind of hand drew this arrow in just based on kind of the other stuff I see. But I think I can make that as a segment on the overall plot. And so if we come back up and do geom segment, and so again, we're thinking in weird coordinates, but like our x and our x end and our y, we need to set those values to draw a segment. And so I'm going to say like this is 2, this is 3. So let's go from like 2.33 to 2.67. And then my outer y is 0.8, right? So this edge here is 0.8. Let's maybe go with this to be 1. So what I'm predicting is that I get a line segment that's actually a curve because I'm in radial coordinates. There we go. We've got our curve. And it's getting the thickness of the line on this legend. It's like it's messed up, right? From the size aesthetic, right? So let's come back up here and geom segment then. We can do line width equals 0.3. And that will then, well, that should have gotten rid of our legend, but it didn't. And maybe instead of geom segment, what I could do would be like annotate geom equals segment on that. And so I think it's not showing me anything because that's outside of the plotting window and it's actually getting clipped. Yeah, so it's getting clipped. So that's fine. I'm going to go back into chord radial and do clip equals off. But to do that, I'm going to need to move these limits inside of chord radial. So chord radial has special limits. So there's like theta lim equals that, right? And then radius, nope, r, what's the r lim? Okay, r lim, and that is going to be this. Okay, and so then clean that up, and that's good. And now we should get our lines. We no longer have that warning about stuff getting removed, and there is our line. And so let's move that out a little bit more, and let's try 2. And let's split the difference and do 1.5. Okay, like that. And so we can put a head on that arrow, on that line, right? By doing arrow equals arrow. There we go. It's pretty ugly. And so I always need to look at the help for arrow because I forget. I think it's this one. Nope, I think it was the other one I wanted. Do this. And so we can set, I'm going to grab all this and throw that in here. And so I think the angle 30, let's see, do that. And so my length, I'm going to put it in terms of points. So I'll do 3 points, and then the ends of the last, and then the type is, I think, going to be closed. There we go. So, and maybe we'd make that a little bit thicker of a line. So I had 0.3, let's go up to 0.5. And there we go. That is, for me, doing the duty of this arrow here, okay? And so maybe we could make that like a dark gray. And let's do color equals gray 30. Let's do 40. Oh, I think I forgot a comma. Yep. There we go. So we've got that arrow now. And well, while we're here, why don't we go ahead and put in that label for the legend, the log 2 fold change, right? And I'm looking at this and I see that the log 2 says a subscript. And so the easiest way I have found to add subscripts or superscripts is to use library ggtext. And that allows us to use markdown in our labels. And I can't use annotate because I'm going to need to use geom rich text. So let's see, where can I put that? Let's put that after the labs. So we'll do geom rich text, and we'll do data equals tibble, and we'll do x equals something, y equals something, label equals something. And then we'll also do, well then I'm just kind of like filling in the stuff, right? Mapping equals AES, x equals x, y equals y, label equals label. And then we'll do color equals, maybe we'll do the gray 40 also. And I need a plus, and I need to spell mapping right. Okay, so then we need to think about the x and y and the label. So let's do the label. So that's the log 2 fold change. So log 2 fold change, and we'll use the BR as the break, the line break with HTML. And so that goes there. And then to get the subscript on the 2, we need to do sub, the sub tags, right? And so, so now let's think about our x and y. Okay, so the x is, again, the theta. And so I'm thinking like this upper left corner is 2.5. So if that's 3, that's 2. Let's put that right in the middle at 2.5. And then our line that I had here, the y was 1.5. Let's maybe make it like 1.7. See what it does. Oh, it's upset. So it's complaining because I haven't included all of the aesthetics and the object protein group not found. So, to get rid of that, I could do like, well, I could add the column here. Or I could also just say inherit AES equals false. And that way then it's not going to get the mappings from that global ggplot2 statement. Yeah, so now that error goes away. I've got that label, and it's centered right where I said I wanted it, right? So let's go ahead and do like hjust equals 0 and vjust equals 1, I think. So we'll left justify it, and I think top justify it. So that corner is at 2.5 and 1.7. Very good, right? Okay, so now we need to shrink down that font and get rid of the label border. So we'll do label.color equals NA. And they've got the British spelling, but we can use that. And then we'll do fill equals NA, which isn't really that important. We can do like size equals 2 to shrink the font down. And so there that is. So that's maybe a little too small. Let's maybe take it up to 3. Okay, let's split the difference. Do 2.6, like so. Okay, and there's also a padding in here, so we can remove that. So we could do label.padding equals unit 0 pt. And so that gets that closer to that line, okay? And so I think that's pretty slick. Maybe we could add a little bit to the y to nudge it out. So let's do 1.75. And I think, yeah, whatever, that's cool. All right. Did I already miss, but why not use this, or is it because it is very busy? I'm sorry, Captain Chuck, I'm not sure what you mean about this question mark. Why did we not use this? Or is it because it's very busy? I don't know. Anyway, cool. While I'm thinking about it, I noticed that their font is different than the default, right? I think the default is an Arial, but I noticed that like the L in log has a little tail. I'm sure there's a special word for that. And the 2 goes straight into the corner, whereas like R2 in the log 2 is kind of curved, right? So these are kind of the little things that I think give just a little bit extra polish and really allow our plots to stand out to be different from other people's. So we can use library show text. And this will allow us to use font add Google. And so you can go into Google Fonts, the website. So I think it's fonts.google.com, and pick out the font you want. I think this is Nunito. And so I'll then say Nunito. It will be the family. And then we need to do show text opts. We need to set the DPI to be 300. And then we need to do show text auto to load all of the show text stuff. Okay. And then what I can do down here in geom-rich text would be to say family equals Nunito. And so now you'll notice my log 2 has that little tail, and the 2 goes straight down in without having that hump. Okay. So again, just one of those little things that adds some polish, and we can add that to the theme by doing text equals element text family equals Nunito. There we go. All right. So let's work on the Y legend, right? Or the radius legend, right? It's out here on the left. And we'd like it to be like theirs in some ways, right? On the axis line, right? And so in chord radial, if I recall right, there is an argument which is our axis inside. And so we can then say true, I think. And so that then puts the axis on the inside rather than on the outside. We've also got these tick marks. So let's get rid of those tick marks. And so we can do that in theme, where we can do axis dot ticks. So there's no tick marks on there. So let's go ahead and remove all the axis ticks. Element blank. And that gets rid of those tick marks. And our font is big, right? And we can shrink that down by doing axis.text.r for that radius, right? Element text, and we'll do size equals 7. And so that could probably be a little bit smaller, so like 6. I think that's pretty close to theirs. They don't have the 0 or the -12. So let's come back up to scale Y continuous. And let's see. Maybe in our breaks, we could do like, well, if I change the breaks, I'm going to change the grid lines, right? And I still, even though I don't want to see the 0, I still want that grid line, right? So what we could do then would be like labels. And we can then do quotes for like an empty string. And we could do seek negative 10 to -2 by 2. And then we'll have another empty string, right? So like what this vector will be a blank for the center, -10, -8, -6, -4, -2, and then a blank. And so now what we see is that we've got the same breaks that they have. Ours is not on the line like theirs is. And so to get it over, we might need to play with the margin. So we could do like, it's already right justified, but let's do margin equals margin r equals 0. And so that moves it over a little bit. So if we wanted to go further, we could then do like -2 to get it over even further. And so let's do -3. And there we go. Our font might be a little bit too small. So let's take that to 0.5. And there we go. Okay. Theirs is like left justified. I don't know that we can, let's see. If we do hjust equals 0. Well, maybe what we could do instead of setting the right to -3, yeah, let's keep that at -3, and I'll be happy with that. Okay. Let's now clean up the background window, or the background of the panel, right? And so we'll do panel dot background element blank. And so that gets us a white background, but we want those grid lines. And so then we'll do like panel.grid.major equals element line. And we'll do line width equals 0.2, color equals gray. Oh, let's just say gray. Okay. And so now we've got our gray lines there. And I'm noticing that this is a minor grid line, and I don't have the minor grid line anymore, right? And also I don't have the axis line around the outside. Hey, Robert from Oakland, welcome. Great to have you. Let's go ahead and get that axis line on. So let's do axis.line. Oh, what is that? I think that's the radius. It gets confusing. Element line. And I'm going to grab all this other stuff because I want it to look like a grid line, right? There we go. Now we have, oh, didn't get it. Oh, it's theta. Must be theta. There we go. It was theta. Okay. So now we have that. And I'm noticing that like the space here could probably be a bit wider. So let's see. My limit on the radius, it's in chord radial, goes out to 0.8. What if it goes to 1? Probably 1.5. Something like that. I think that looks good, but then this stuff needs to move out. So that was it here, right? And that was the Y. So let's take that to 2.5. Nope, that, yep. Yeah, 2.5. Well, that's the label. That's not the line, right? So I need to move the lines. That was the geom segment, or the annotate segment. And so let's take this to 2.25. Yeah, I think that's cool. All right. Yeah, the label, yeah, that's fine. All right. So now we've got that borderline like they did, but we don't have our minor grid lines. And so something that I'm not sure about with these labels for the theta is if we can move them in to be on top of the line. And ultimately, well, I guess I would try like axis text dot theta element text, and then like margin equals margin, r equals like -5. I don't feel like that did anything. Or if I do bottom -5, that didn't do anything. So I think what I'm going to do is remove these outer labels and then plop them directly on the spoke. And so let's go ahead and I'm going to do that also with geom rich text, because one of the things that I kind of don't like, I mean, there's many things I don't like, but with this is like if you look at the 6, you can see the lines behind it. And what I think would be a cool effect would be like where you have the number is to basically have a like a white cloud around it so you can't see the background. So that's what I'd like to try. So let's come in here and we'll do geom rich text again. Actually, we could do this with geom label. It doesn't matter, but whatever. We'll do geom label, and yeah, we'll do data equals Tibble, and then our x, again, is going to be these theta values. So let's do 0, 2, 4, and 6. And then our y is going to be the outer edge, right? And so that outer edge is the y, or the r limit, so that's 1.5. And then our label will be the same as x. And yeah, let's see what that does. I suppose I probably need to give it the mapping, right? So we'll do AES, x equals x, y equals y, label equals label, and then we'll do color equals black. And I'm probably gonna have to do inherit equals false. Yeah, I have to do inherit AES equals false. That's fine. And there we go, right? So I don't want, oh, yes. So I see a few things going on here. Thing one is that the outer line, the axis line, is going over the label rather than behind the label. And I think what that means, and I've seen this before, like when we have like an x-axis in Cartesian space that goes from like 0 to something, 0 to 100, and I have data at 0, oftentimes it gets hidden behind the y-axis line. And so in those cases, what I have to do is use something like geom line to draw the line under the data. So I think I have to do the same thing here. So I'm going to go in. So I had that axis line theta here. I'm going to comment that out for right now. As we see, that goes away. And so then I can come back up here. And so again, before the points, or really before, before what? Before the label. Let's do it here with the label. So we'll do geom. Again, what is this? I'm getting confused. I think it's going to be H line with a y-intercept. So it's like a brain twister for me, at least, going between Cartesian coordinates and radial. I think in Cartesian, and so I'm translating everything to radial, which makes things hard, right? And so here then, the y-intercept will be 1.5. And there we go. Now we have our axis line, but of course, I want it to match all this stuff. So I'm going to go ahead and grab that, delete this axis line, and then put it in here, like so. Okay, so now I've got my line, and it's going behind the label. I can also get rid of the axis text theta, right, by doing element blank. And so that gets rid of those. I would like to shrink down, well, the number and the amount of padding. So again, that's going to be done in here. And we also need to add the family equals nunito and size equals, well, let's do size equals, I think it was 6.5. Let's do 7, and size unit equals PT. So one of the nice things about using geom label instead of geom rich text is that I can set the size of the text using points, whereas I can't do that with geom rich text. I have to use, it's basically millimeters, right? So anyway. So that shrinks the number down, I think, to a good size. And then we have this border around it that I don't care to have the border. So let's go ahead and get rid of that border. And we can do that here, right? We can then do border color equals NA. And so now we've got those numbers on the spokes, but we don't see like the lines running through the number. I think that's a little bit nicer of an appearance. We could shrink the size around it by doing something like, I think, label.padding. And I could do like unit 2pt. And so I don't know if you can see it. Let's do something like 1. And so I think that made it a little bit tighter. I think 1 looks good. I'll roll with that. But what we're missing then are the minor grid lines on the theta, right? So let's come back up to our, again, that's scale x continuous, and we'll do breaks equals seek from 0 to 7 by 1s. And so now we've got all of those grid lines back in, and that's cool. Let's see. Take a drink and think. All right. So what to do next? Let's go ahead and I'm going to do the legend last, just to let you know. Let's go ahead and do these titles. And again, we'll do that with element markdown because we've got the superscript and we've also got the color, right? And then what I'm going to do is I'm going to make the strip text. So I currently have EF and G. I'm going to replace that with what I've got highlighted down here. So like this radius label will be part of the title of the strip. So let's go ahead and grab that. And I'm going to come up here and I'm going to make a pretty label vector. And we're going to have like E equals something, F equals something, and G equals something. And so let's go ahead and plop this in. And it's going to have the line break, right? And so negative log 10. I'm going to remove the negative because it's not a negative log. And so this is also my C, 3 my C. And so this needs to be a superscript. And we'll back out of it here. And I'll hold on to the color for right now. And I'm going to copy this down. And I think it's turbo, let's see, 3 my C, turbo ID vex2. And then here it's vex2. I think hyphen turbo ID, yeah, like that. And then we have like the same thing here, but vex1 for G. Okay, so we'll get this loaded. And so I can use this pretty label down in facet wrap, right? So right here, I can do labeler equals labeler, and then I can do panel equals pretty label. Okay, so what this is going to do is this is going to change the labeling of E, F, and G, right? So instead of E, F, G, hopefully I get this, right? And it's not because I don't have the element markdown in yet, but let's run it and see what we get. Right, and so now we've got the HTML up there. And I can then come in here and do strip.text equals element markdown. And now, very good. Now we have the markdown. We have the formatting matching what they had. My font is a little bit bigger than theirs. So let's go ahead and shrink that down. So we'll do like size equals 7. Maybe that's too small, so let's do 8. I think that's good. Let's go ahead and get rid of the margin around it. So we'll do margin equals margin, and by default, it's basically giving me 4 zeros all the way around. Right, so that cleans that up. Let's now get the colors in. And again, if we come back up to where I defined this, it's the vex2 and the vex1 that is being colored. So I'll use like a span, and I'll do style equals, and then in quotes, color colon something, and back out of the span here. Okay, and so then the color for this vex2 is the purple. And I know I have that already in here, but whatever. We'll do that. And then I guess I'm going to go ahead and grab this span and replace it here with that vex2 and here with this vex1. So I need to get the right colors. And so vex2 is the burgundy. Right, it was actually it's already this, right? That's right. So it's the vex1 I need. And that is this teal. All right, and then that there, move that extra pound sign, and then get everything all loaded. And then we now see that we've got those labels. Cool, right? All right. So one challenge, well, what I'd like to do is like give more room to the 3 radial diagrams. Well, hold on. Let's do the legend. All right, sorry. So let's do the legend. We're getting, I think, pretty close. So again, this is similar to what we did last week with the section headings in the legend, and that we're going to use different different scales to get the effect we want. So we've got two scales here already, size and fill, and I can include in let's see, I'm going to switch the order here just for my own peace of mind. So I'm going to work on the fill first. And so what I'll do is let's come back up to where we did geoPoint, and I'm going to do show legend equals true. And let's see what this looks like. Okay, so we've got our legend here. And in my scale fill manual, I can now include the breaks that I want to show. And so the first one that I'm going to show is the vex1 and the vex2 and the calf, right? So let's do, and I'm going to put it in the order of vex1, vex2, calf. So let's do vex1, vex2, calf. And I think what I should get is a scale legend for the fill that only has those three values. Sure enough, I have a legend with those three values. Cool, right? All right. So let's put a pin in that. And so now let's think about this enriched in biotin. And we'll do that then with the size, right? So again, what I did was I could come in here and do breaks equals, and it's going to be the significant. And so now what I see is that I've got a spot for significant, right? It doesn't have a color. It's got a size, right? But this is a legend and this is a legend for significant. And now what I'm going to do is make another legend for these validated components. Basically, I'm treating these three items as three legends, okay? And I'm thinking of like this vex known inhibit actors and this, those are the titles of the legends, okay? And that we can get rid of like the vex1, vex2, calf, and significant to put them next to each other, okay? So that's where I'm going here. So we need to add a third component, which I will add as alpha, because again, it's another thing. And so let's do alpha. And we will then do, we've got these values, and the alpha for all of them is going to be 1, right? So we'll make that one, and this one. And then the breaks here, I'm going to put in validated, okay? And I need a comma here. And so this is going to complain because it's going to say no shared values, manual scales, and the data alphas. And that's because back up here in ggplot, I need to say alpha equals protein group. Okay. And so now it should work, where again I've got validated up here. All right. Now what I want to do is let's get these to lay across the bottom of the plot. And so we'll come in here and we'll do a legend dot position, and I'll say bottom. And so now I've got my legend across the bottom. But again, I am going to, and I want these in different orders, right? And so there's a couple things I need to do here. So first, let's go ahead and so let's see. I'm thinking about the labels that I want to use. And so I think I can do labels equals C and then 3 empty values. Right? So now I've got those 3 dots next to each other. And what I can do then back up here with scale fill manual is this vex known interactors, I'm going to make that the title. right? And so now I've got my vex known interactors as the title next to the 3 points. But I want this on the right side. And wouldn't you know it, but that there is a legend argument in theme for legend title position, and I can say right. And so now I have the title on the right side, right? Cool, eh? I'm going to do the same type of thing with validated and significant now. So I will come back up here, and I'll do labels equals nothing. And I'll do the same thing here for the validated. And I'm sure instead of labels equals nothing, down below I could do like legend text equals element blank, but this will be cool. Let's just roll with this. And so now for the title for the significant, it's going to be this, right? So I'm going to go ahead and copy that, plop that in, and again we've got a line break, so I'm going to use \n, and then for this, I'll go ahead and copy that into the title, and then \n on that. And we've now got our 3 legend components. But our text is too big, and let's also do legend.box.spacing, and I'll do unit 0pt to get that a little bit closer, and then legend.text or legend.title equals element text, size equals 8. Shrink that down. And so I now need to make these points colored and larger, and I need to kind of clean up the spacing and get the order right, okay? So, so Mike is saying that the P in title is italic. Also the 10 is subscript. Oh yes, up in the title. Let me get that real quick. Thank you, Mike. So we can do that again with this sub, and then with the P, I can use the stars to make it, that's the markdown for the P. And there we go. We've got the log 10 and the P is italics. Awesome. Let's see. Okay, so now we need to, So what we're going to do is back up here in these scales. So like the scale fill manual, I'll come in here then and do guide equals guide legend. And I'll do override AES, and this will take a list. So I'll do list, and I'll do like size equals 5. And so that makes those circles bigger, right? Which I think is maybe a little bit too big. Maybe it should be like 4. Yeah, I think 4 works well. And down here, I could do like legend.key.spacing. And I can do like unit. What happens if we do 0 pt? That brings those together. I think it's like saving room for the text. So let's do legend.text equals element blank. No, that didn't do it. Let's do like -4. So that pulls that together. And then maybe like, yeah, that pulls that together. We'll futz with the formatting here in a minute. So now let's come back and look at these other guides, right? And so I'm going to go ahead and come into the size, and I'll do guide equals guide legend and override AES list, again, size equals 4. And the color we want, this again is significant, is the purple. And so then we can do fill equals this with a pound. Does that do it? Yeah, that gets us our purple circle. And so now we need the red, and we'll do the same thing that we had here. Get that, and I think I need another parenthesis there. Okay, and so we want that pinkish color, and so I'll get that there. And there we go. Cool. Now, I think our symbols are a little bit too close to the text, and so I think like legend title, I'm going to do like margin equals margin L equals 2. And that, maybe it could go down to 1. Not a big deal. Cool. All right. Now we need to get the order right. And my understanding is that the ordering of the scales is random, basically. And so to get it right, we can again come down into this guide argument. And within guide legend, we can do order and then specify the order. So this is the second one, right? And then up here, this I want, I don't think I got in. Okay, right here. We can do order equals 1. And then for the alpha, we'll do order equals 3. And there we go. We've gotten the order of those components correct. Okay, now let's go ahead and I guess one subtle thing that I can share with you. So let's, so one problem with these radial plots is that the way they're constructed is that they're actually saving room for like the axis titles, which I don't need, right? And so there's a lot of extra white space in here that's going to waste. So let's try to deal with that by first removing the margin from all the way around the plot. And so I'll do plot.margin equals margin. There we go. And so it appears like we have big margins on the left and right. And that is because, why? That is because this is like a special version of chord equal, where the size of like one unit on the y-axis is the same on the x-axis. And so to kind of get the aspect ratios right, it looks like there's extra padding on the sides. So whatever. But to kind of see where this is, I could do like panel.border equals element rect color equals red. Right? And so that's like where the border is. So you can see there's like a lot of white space around the circle that is going to padding. So, and I'm noticing like my legend appears to have, I think it has a white background, and you can kind of see it kind of encroaching in up here. And I think there's, I think it has its own margin. So we can do legend.margin equals margin. Right. And so that, again, tightens it up a bit. To kind of show you what I mean, if I did like legend background element blank, we no longer see it kind of like encroaching in that line, right? Something else we could do is the panel spacing. And we could do like unit 0 PT. right? So that kind of pulls that in, but we are still using a lot of white space. And so something that I found as I was investigating this was an issue in the ggplot thing repository for dealing with the same issue, right? Like they're making pie charts, but like they're talking about like the pie should fill the entire gray area to look more like this. And so what was suggested, I don't know if you can see it here, was to add this to the plot, basically a ggproto statement. And what we could then do is modify the inner radius to be 0 and 0.5. And I want to check something out first, because I thought I saw something when I was looking at the chord radial help here a minute or two ago, is that there's an inner radius of 0. Oh, so that's the size of the inner hole. Okay, so let's come back up. So where I had my chord radial, and here I can do ggproto null. And at this point, I do not know what I'm doing. I'm following basically the example that they had in the issue tracker, okay? So that is full disclosure on that. So basically ggproto is going to take null, my chord radial statement, and then a value for the inner radius of 0 and 0.5. I want to try something. I wonder if I can use this directly in chord radial. So let's try this. I feel like it's changing the inside of the thing, right? The inner radius. Can I do 0 and 0.5? Let's see. Nope, it has to be a number, not a double vector. Okay, so much for that idea. So again, we'll go back to this and we'll do ggproto null, and then we've got our chord radial. And let me just kind of clean this up here a bit. And then this closes that. And then we have inner underscore radius. If I recall this, right? Yeah, again, I don't know how this works. I'm just following this recommendation. And if we run this, no errors. And we can now see that it blows out to use the full space. So I don't know that I want 0.5. Maybe what I would like instead would be like 0.45. So let's try 0.45. And I think that is better. Maybe, yeah. I think that's better. So let's go ahead and get rid of that red boundary that I put in here to kind of see where it was. And then we also want to remove the strip background. So we'll do strip.background equals element blank. And there we go. So this is maybe what I could do actually would be to bring the title, the text down a bit. So this is the top. If I do like -5. Oh, that wasn't what I wanted. I think I wanted the bottom to be 0. So top right, bottom. And so it clips in the strip. And so we could add then to strip dot clip equals off. You can probably notice that this is actually taking a beat to run. It's a little bit slower than maybe we're used to seeing. But and so that then I think does a better job of filling out the space. So, and maybe we could put margin around the top and the bottom. Something like that, okay? So that's as far as I'm gonna take recreating their plot. There are a couple things that I have not done and that is to place these labels. And I would probably suggest placing the labels, again, using like geom text, okay? I'm not going to do that just because we have like 20 minutes here, and I want to show you a better way, right? So I'm going to save this, and I'm going to copy it into a new script, and I will, let's see. Oh no, did I just brick up my computer? Nope, okay. So we'll call this radial volcano invert, okay? So again, one of the critiques I have of this is that the data is like, well, first of all, I'm showing log 10. They're saying they had log 10, negative log 10, but they didn't. They had log 10, right? So what if we flip the radius axis? And aside from being like true to how a volcano plot is typically created, the other thing that that will do is all these gray points that are not significant would get shoved on the inside. And actually, there's one thing I didn't include. Let me go back to this. And that is that grid line, that dashed line on the inside of the panel, right? And that should go in the background. So I'm going to put this before my geom point. So let's do geom, and this is going to be H line, and we'll do Y intercept. I'm going to put 0.05, and let's see what this looks like. And so that's at 0.05. Right. I need to log that, right? Because I've already logged it up here. Let's see where I'm. Okay. I've already logged it up here. So I need to do the log 10 of this. Okay. So log of that. There we go. And so, again, it's subtle, but like this is crossing right at about like -3, whereas if I zoom in on theirs, it's higher, right? And yeah, so I think when I had looked before during the critique video, I think I had found that it was actually at like 0.025. Nope. Well, let's do. Now I'm confusing myself. Sorry. Let's. Oh, that's log, not log 10. Okay. All right. So 0.025 is outside of that. And actually, let me go back and do 0.05 log 10. So if you just do log, it's a natural logarithm, not log 10, right? So this is where 0.05 would be, right? And you can see that that does not jibe with what they've got, right? And so I think what they plotted was 0.025, 0.0025, right? Which is inside like that, right? So again, that's unfortunate because as they say in their plot, right, like these are the ones less than 0.05. Also, these are P, as you'll notice, not P adjusted. So, all right. Let's come in here and let's do line width equals 0.5, line type equals dashed. Something like that. Okay. So, all right, I think that's pretty good. So let's, now I'm confusing myself again. So as I look at this, no, that's right. Okay. Yeah, I'm getting confused. All right, so we're good. So again, I'm going to go ahead and save this and copy and paste. Oh, let's try that again. Copy and paste. And so then I'll call this invert. And let's rerun everything. And this should all look the same, right? So it looks the same. And so what I want to do, again, is to make it negative log P10, right? So if I come back up here to be negative log P10, and let's see, so let's see, up here, so y should be negative log of that, and we'll want like the negative log here as well. And so this is probably going to move around a lot of stuff, but that's okay. We'll get that figured out. Yeah. Awesome. So the first thing I think to change is our limits, right? So instead of spiraling in, we're spiraling out. And so we're starting at like 0 and going out to like positive 12, right? Rather than starting at 0 and going in to negative 12. So let's come to scale x continuous, and I'm going to do from 1 to 12. And then here, I think I'm going to go from 0 to 12 by 2. And it's upset about the size for some reason. I think I must have screwed something up. Oh, this should be seek. All right, so it's still upset with my scale y continuous. Oh, maybe 1 to 12. Right, because you can't have 0 log. All right. What am I doing wrong? Let me check my limits then on chord radial. Right up here. Right. So let's go from 1 to 12. Like that. And so these numbers are my, what? Those numbers are my axis text, right? So let's go ahead and move those back out. And that was geom label, so put that to be 12 on the y. Okay, so that got that out. And we also have that geom H line that we made for the axis, right? And so that that's the dashed. The geom segment is the arrow. And so let's actually put that at 12.25. And I think I put, yeah, the geom H line here. So let's make this 12.5. All right, so that's probably further out than I wanted. So let's make it 12. There we go. Cool. Now we still have our label on the inside, and that was the geom rich text, right? So let's put this to be 12, like that. Okay, that probably needs to go a little bit further out. So let's make that 12.5. Like that. And you know what? I think that needs to go a little bit further out still. So let's make it 13. And then our arrow, oh, where did you go? Right there. Okay. So that's 12.25. Let's make this 12.5. Like so. Right. And so as I'm looking at this, like trying to make sense of it again. And so I think this actually yeah, something's still off because I've got purple points on the inside. So let's come back up, and so that's negative log 10 point. Oh, right. I know what the problem is. That right. So too many purple points here got colored because it wasn't 0.05, it was 0.0025, right? So let me come back to this other one, and where I was defining the significance in that case when, that 0.025. Okay, so that matches theirs, right? And then with this new one, with the inverted, we're going to again do that case when to be 0.025. And here we go. Okay. So now what we see is that these smaller gray points are at the inside of the circle. They're not significant, right? And maybe we could get a bit more separation on the inside by having it go down to 0. So if we come back up to chord radial, I think, oh, and that was with the GG Proto weirdness. Let's put a 0 in there. So that gets a bit more spacing. I don't know. So I think with my refactoring of it relative to theirs, again, it's hiding the non-significant data, right? Whereas in their version, it's kind of giving emphasis to the non-significant data, right? And then it's basically compressing all the points in with theirs by cycling in, whereas mine by cycling out is giving, I don't know, more space, more room to breathe, so to speak, right? Hey, Dr. Abdul Rahman Shahab, welcome. Yeah, so the question of a conventional plot. So again, there's tinkering that we could do with this and kind of thinking about this. The other thing that I haven't talked about is that they're using the p-value. They're not using the adjusted p-value. And I think they should be using the adjusted p-value. I don't have time to go back and use the adjusted p-value, or let me do that real quick maybe in my radial. So where I have p-value like this, so I have adjusted p-value. Maybe what I could do actually is swap like this, right? So now p-value equals adjusted p-value. And that gives you far fewer points that are significant, I think. And we could then zoom in a bit more, right? So here I'm going out to like 11 or 12, but we could zoom in. So this is 7. So if you go to like 8 on chord radial, and then that's going to throw off our arrow and our labels, but that's all good. That's beautiful. Let's come back up to geom H line. Let's see. Oh, that was, sorry, probably giving people whiplash going back and forth like this, but hang in there. So this should fix the axis line and the axis text. And then if we come back here, I subtracted 4, so let's make that 9. And then our arrow was geom segment within an annotate right here, right? So let's make this 8.5. Like so, okay? So then this is using the log p adjusted. And so maybe I could come back up here and then do sub adjusted, sub let's see. Yeah. So it's by no means perfect, but I like mine version better than theirs. I don't know what you think. But the question of like, why, why are we doing this in radial coordinates, right? So let me go ahead and copy this into a new script. And let's call this Cartesian, okay? And let me just rerun everything to make sure it works. Also save this as Cartesian volcano.r. Oh, I think I reran it. And so, right. So we haven't changed anything. But let's go ahead then and remove this, right? And rerun it. And I think yeah, I forgot a line. Okay, now let's try it. And there you go. This is okay. I'm just kind of taking it in here for a moment, so just give me a second. So how would we fix this? So let's fix this by removing this geom H line was for the axis, right? And so was this. So I'm going to go ahead and comment this out. And then we had axis text y x. I think I want to replace this with element text. We'll do size equals 6.5. And I thought I had an axis line. Let's do axis.line equals element line color equals black. Line width, let's say like 0.3. Oh, axis text T, Y. Oh, theta, that was the X. This is the Y. Okay. All right. Let's go ahead and add back in that panel spacing. Like that. And we lost the title, so axis title. Did I lose it? Oh, I did it as labs null. So this on the x-axis should be the log2. It's this, right? And so I can then comment this out, plop that in, and then the y-axis is the log10p adjusted, which we can get rid of. Cut that out, and then bring that down to my labs. And get this in quotes. And it's not going to look right just yet. So that would be axis title. Element markdown. Axis title. Well, let me go ahead. I know I need to rerun pretty label. Let's see what this does. Why isn't it rendering? Axis, title, element markdown. Let's try .x. There we go. Okay. I guess I have to separate them. And I know that this, I have a break in here that I don't need. So let's go ahead and get that. Kind of like so. And then I think my strip, I added that margin to pull it down. Let's get rid of that. And then I must be doing something weird with my axis text with this margin. Let's get rid of that. Like that. So and maybe we can add a margin on the left and right. Right. I'm afraid this is probably going to have to do it for today. But again, showing 3 different ways where I've recreated their plot that I didn't particularly like, recreating it by flipping the radius axis and then removing it from the radial scale, right? I see I still have that arrow there that I need to get rid of, but whatever. You know, I can kind of see in my radial format where things are spinning outwards, where you might get more separation of the data than you do here. But, you know, and because this also gives a lot of highlight to like the non-significant points. I don't know. I still think I still think the traditional is where it's at and what they should have done. I don't know why they chose the radius, except to perhaps make it a little bit more fancy and cool. But I assume that they probably did a lot of what I'm doing in Illustrator because this is hard. If you can't tell, my brain has been kind of racked. And in full honesty, I did try to recreate this before being with you recording this. And so making this is hard, right? Like this takes a lot of technical skill that I suspect they did a lot of that in Illustrator. Just kind of little signs that I can tell that tells me they did it in Illustrator, but I don't know. Whereas this is a lot easier to do. But anyway, let me know what you think. Again, I did not get either of these plots to a state where I would be happy publishing them, just to be perfectly clear here. And that's okay. Maybe I'll clean up a little bit of stuff before I post it. But hopefully you get something out of this. And again, this question of should we be recreating plots that we don't think are good? I say yes, because ultimately this helped me to see that they were plotting the actual p-value, that they did not invert the sign of their radius axis, right? And so I probably would have taken me a lot longer to figure out how to do that if I hadn't recreated their data, right? So anyway, let me know what you think. Please feel free to leave a comment below. I'm sorry for going long on this, and I will talk to you next time for another episode of Code Club. Take care.